Hi there. I'm going to give you a quick walkthrough of PlaceBot, a multi-vendor AI locality processor. PlaceBot is an AI-assisted Python package to streamline the georeferencing process for specimen data, which is especially useful when dealing with museum vouchers, which may have partial or outdated place names. Manual georeferencing is slow and doesn't scale to the billions of specimens in global natural history collections, or those occurrence records on GBIF that lack existing coordinate data. So PlaceBot uses artificial intelligence to search for locality based on user-supplied text. It structures the output into various geographical hierarchies like country and state and region and sector, and provides estimated coordinates. If coordinates are already provided, such as degrees, minutes, seconds, or in grid referencing formats, PlaceBot will then convert them to standard decimal degrees. If multiple identical locality strings are provided, it will deduplicate before searching to save on costs and compute. The PlaceBot Python package provides access to multiple AI vendors, including major cloud and local providers. And it provides a benchmarking dataset that has been georeferenced manually to assess each of these AI models. I'm going to walk you through how to install it and then how to run it. Here you can see the GitHub repository, and the easiest method is either through going to one of the releases and downloading the appropriate operating system. So for example, here we've got the Mac version and the Windows version. Or if you're that way inclined, you can go and use pip. So it's a Python package called PlaceBot. Pip install PlaceBot will get that onto your system. Now, having a look at the overview, you can open the software by either using the icon, double-clicking that, or in your terminal by typing PlaceBot for the command line version, or PlaceBot-GUI for the graphical user interface version. And what that'll do is open up another terminal window and then open up a browser on your computer. And here you can see the software running. So I'm going to give you an overview of the program, and we'll run through some data together. There are three options that you can see here on the top left-hand side. You can process data, you can download data that you've processed as a batch, and then the third option is to do an ensemble analysis once you've analyzed data from various providers through various AI providers. And you can see where you can put your API keys here. So API keys are not saved on in the system by default. However, you can tick, please remember this API key on my computer. And they're not shared with anything else. The API keys are used by the program in the background to query those AI providers. You can see we provide access to the major providers, so Anthropic, OpenAI, Google's Gemini in particular, and then OpenRouter. And if you have local models through Olama, you can set them up on your computer and then link them into PlaceBot. So running it is relatively straightforward. You can upload your own data in CSV or TSV format. Or you can pick some of the data sets that are in the input folder here. So I'll show you a few. So here are some example data sets. You can analyze, and once you've loaded a data set, you'll see a preview of that data set below. So you can see that it's loaded up properly, and PlaceBot will check if there is a field that it thinks has locality text in it here. So for example, here, locality verbatim. You can choose how to process the data. So you can do it either in real time, where it queries one at a time, or you can send a whole batch of records off to be analyzed and then downloaded later. That's much cheaper. The AI companies prefer to offload those sorts of requests into times when they have less compute requirement. And then for very large batches, if they're over 1,000 unique localities, we have a staggered batch approach, which is useful in particular for Google Gemini. And what that'll do is use multiple AI keys and stagger the delivery of those batches over time so that you don't get into run into issues with too many queries to the API. There are a bunch of models already included, and we'll be adding new models as they are made available. You can see here the 3 Anthropic models, 2 from Google, and then a few from OpenAI. And you can also have the equivalent through OpenRouter or the local Llama models. So in this case, I'm going to select the AI test. I'm going to pick Claude Haiku. And it's going to give me the number of records, the estimated cost to do the analysis. And the savings here are based on caching of the prompt so that the prompt is only sent once and then every record, which is much smaller, is sent along. And then you can select how you want your data, in what output format you'd like it. So for example, you could have it as a spreadsheet in CSV format, or you could pick it as a JSON. And then you can also specify whether or not you want to use the default behavior, which is the input columns that you gave it will be the output column names that you get out the other end, or you can ask PlaceBot to convert everything into Darwin core for the output. And you can also select deduplication of repeated localities, and that'll save on processing power. So if we click Start Processing here, you'll see that it's begun processing. There's only 5 records. It should take less than a minute. Some models are a bit faster than others. And there we go. So it's successfully processed those 5 records. It's saved the data in 2 formats automatically as TSV and CSV into an output folder on your computer. If you click Open Folder, it will then open the folder for you so you can see the results. And you can see a summary of the results presented on the screen here. So here we had our 5 records, the locality verbatim that was given to PlaceBot, and then the processed country, state, region, sector, the exact site, and then the latitude and longitude, whether or not the coordinates were estimated or extracted. So those record number 2 and 3, you can see that originally they actually had coordinates in the string. And then there's a radius applied in meters, confidence by the AI model, and then processing notes where the AI model has explained how it got there, in essence.